Okay, this is after the fact. I have completed Advent of Code 2021 day 16, and oh boy, this one took a while. I decided to spare you the trouble of watching like an hour-long video of me just trying to figure out what was being asked. So basically, we're given a huge hex string, which you convert to binary first, and then within that there are packets, and so these packets um, they each contain things like the version and the type ID, and some of them can have children within inside of that packet. So it's similar to one of the 2019 problems, where there's packets or something contained within each of the data sets. And so you have to recursively get each of the insides of each packet. And so in part one, those versions that each of them had, you just had to figure out the sum of those. And then in part two, things get a little more complicated. So before there was what was called literal values. These were for like packet just represents a number. But then separately there was what's called operator types. So the different operators are 0, which is take the sum of all its children's values, product, minimum of the children, maximum of the children. If the first child is greater than the second, first one is less than the second, or if they're equal. So you had to compute the value of the whole string, because the whole thing is one big packet, and it contains a bunch of smaller packets inside, which may or may not contain packets. And so in the end, this is my implementation. So they provided this dictionary at the top, or the values used. I just copy pasted it in. And so I used a class for this. So it's a packet. And first we get the inside of the packet after setting up, getting the version and type ID. So to get the inside, there's two types. When it's type 0 for the length type ID, then you interpret it this way. You look at the next 15 bits, and that's the number, the total length in bits of the subpackets contained in it. So that's like how far ahead to look, basically, in the whole big string. But if it's type 1 instead, then it's how many packets are inside, so you don't know the length in that case. So once we've done that, then let's say it was an operator packet, which this had to have been. So this gets the children for this packet, because you can't apply the operator until you know what its children are. So it's basically depth first search is what this is doing. It just makes a new packet and adds it as a child to this one. So once you have the children, so I used the match case. It's new in Python 3.10, and so it's pretty straightforward. You just apply the function that they said. So most of these, actually all of them, built into Python. Product. This is math.product. It's the same thing. Min, max, and the children comparing first and second values. That's really easy. Just convert the Boolean to an integer. Okay, so if it's a literal instead, then in that case, we interpret it kind of differently. So this part was kind of confusing because they mentioned that you're supposed to pad the binary number, which I guess I didn't realize. Like, this kind of takes care of that, I believe. Which actually I feel like it shouldn't. But yeah, I didn't do anything to pad the strings and it worked, so I don't really know what they're on about. So I'm using split after. This is similar to take while, except it splits after. Like, it takes the last element where the condition is false as well, and then it splits it up that way. And so I just get the first part of that. So it's as if you called take while and then called it again, called it again. I just want the first time that it's called. That's what split after does. This is from more ITER tools. And chunked, I've kind of shown this before. It's basically given a list and it splits it into size of whatever you say. Again, it's for more ITER tools. And so, if you're going down a path of one of the strings, then it might be like, well, I still need everything that was after this initial section. So that's what I have this extra variable for. It's basically take everything that was after this part of the packet and look at the next packet that's part of the children of the higher up one. It's really complicated. In all my testing, I was doing all the assertions because they generously provided a lot of samples for this one, which this would have been like impossible to do without these. But so in the end, when we run it here, then my part 1 answer was 981, and then it's like 2 billion something, so I feel bad for people finally get to this point and then you get overflow or something, you get stuck on that. So let's hope things aren't as bad tonight's problem. It's like kind of hard for still having 10 days left, so we'll see how things go. But thanks for watching.